Hello friends. On August 3, 2026, Alibaba released a model called Qwen 3.8 Max. And right away, one number stopped everyone cold. 2.4 trillion parameters. A parameter is basically a tiny dial inside the model, a number the system uses to think. Most powerful models have billions. This one has trillions. That sounds impossible to actually run on any real computer. So here's the question we are answering in this video. How does a 2.4 trillion parameter AI actually run at all? The answer is a clever trick called sparse mixture of experts, and once you see how it works, the whole thing clicks. To understand the trick, you first need to see why the obvious approach completely fails. In a standard dense model, every single parameter does work for every single token you send it. The compute cost per token is roughly 2 times the total parameter count in floating point operations. So a dense 2.4 trillion parameter model would need around 4,800 billion operations per token, plus roughly 4.8 terabytes of memory just to hold the weights. No single machine on Earth can do that comfortably at inference. Dense scaling is like hiring 2.4 trillion workers and making every one of them show up for every customer. It simply does not scale. Here is the core idea of sparse mixture of experts, which we will call SMoE for short. Instead of one giant feed-forward layer where every neuron fires every time, you split it into many smaller subnetworks called experts. Think of it like a hospital with many specialist doctors. Each expert handles certain kinds of knowledge. Now you add a lightweight router. For each token you send in, the router quickly scores all the experts and picks just the top few, the top K, to actually process that token. Everyone else sits out. This means only a tiny fraction of the total parameters ever activate at once. And that is exactly how a 2.4 trillion parameter model stays fast. Next, let us look at the exact numbers behind that fraction. Alright, let us put real numbers on this. Qwen 3.8 Max has 2.4 trillion total parameters, but its router activates only 95 billion of them per token. That is roughly 4% of the total. Now remember, a dense model costs about 2 times its full parameter count in floating point operations per token. A dense 2.4 trillion parameter model would need around 4,800 billion operations per token. Qwen 3.8 Max only pays 2 times 95 billion, which is 190 billion operations per token. That is about 25 times fewer operations than you would expect from the headline number. The compute cost tracks the active slice, not the full archive. So when you see 2.4 trillion parameters, the number that actually drives inference cost is 95 billion. Next, we need to talk about a hidden danger that can break this whole system. Here's the hidden danger. Left alone, the router learns bad habits. It finds 1 or 2 experts that seem useful early in training, and it keeps sending them almost everything. Those experts get overwhelmed, the rest sit idle, their capacity wasted. This is called expert collapse. Think of a restaurant where every customer requests the same one waiter. To fix this, engineers add a penalty during training called an auxiliary load balancing loss. Loss here is just a score the model tries to minimize. This penalty increases whenever traffic is uneven, so the router learns to spread tokens more evenly across all experts. Every expert gets trained on a fair share of data. When inference time comes, all that capacity is ready to use. A simple training nudge keeps the whole system healthy. Now let us zoom out and see why this architecture is taking over the frontier. So here is what SMoE actually unlocks. Instead of paying for 2.4 trillion parameters at inference time, you only pay for 95 billion. But you still trained 2.4 trillion parameters worth of knowledge. More knowledge, same inference cost. That trade-off is so powerful that SMoE is now the standard design for frontier models. Qwen 3.8 Max, which launched just yesterday on August 3rd, runs on it. So does Qwen3, the largest open model right now at 2.8 trillion parameters, launched just last month. Llama 4 Maverick and DeepSeek V4 Pro use it too. Sparsity keeps getting tighter, from about 25% active parameters in earlier models down to about 4% today. Here's the key takeaway. Total parameters measure knowledge, active parameters measure cost. SMoE separates the two. That gap is what the frontier is racing to widen. Thanks for watching, and we will see you in the next one.